Good afternoon. Thanks for joining us here in the room and out there in Teams land. I am Laura Grabowski, computer science faculty, currently serving as department chair, and I am joined today by my most excellent colleagues, Dr. Supraja Gurujala and Dr. Brian Ladd. So we're kind of the opening act for this seminar series about AI, which has in recent months kind of exploded into the public consciousness more than it had been ever before, really, at least in terms of practical sorts of applications, as opposed to in science fiction films. I'd like to first of all just kind of set the parameters for what our discussion today is going to be about. We are going to be focusing on some of the technical aspects of AI, focused more in the academic realm. Okay, so how that intersects with academia. So we're not concerned about the social and ethical applications and all of those very difficult questions. We are in no way trying to minimize those issues because they are very big, but that's just outside the scope of what we're going to talk about today. So the way that we have organized our presentation, first of all, Supraja is going to talk a bit about how AI works, how we train it, what it can do and what it can't do. And then Brian has a bit of a demo to demonstrate some of those cans or can'ts. I'm not sure which way that actually, maybe both. And then I'll talk a little bit about detecting AI. So with that, I think as soon as we can share a screen, we'll be ready to go.
Maybe Laura just mentioned that at the end we'll open it up.
Oh, yes, I'm sorry. Yeah, so that presentation bit, we're hoping it to be about 20 minutes, and then leave a whole lot of room for talking and answering questions as we can. I'm not going to guarantee we can answer all your questions, because we don't have the keys to the inner workings of all of these systems specifically, but we do have the essential technical understanding of how they work. Yeah, that was a very important part. Sorry about that.
Good evening, everybody. I'm Supraja Gurujala, and I'm going to give a little intro to how the generative AI works, the generative artificial intelligence. So there are a few steps involved in how this whole thing works. First and foremost, what does the generative AI do? It basically uses machine learning techniques like deep learning and neural networks and all those algorithms, and it's going to learn from a data set, and it's going to try to generate content that is somewhat similar to the data set. Okay, that's like the gist of it. So the process involves, so let's say, for example, if you want to generate an image of a dog, right? So the process starts by collecting data, basically examples of dog images and things like that. The collection of the data is the most important thing. A really large collection of data set that is similar to what you want to generate. Okay, so that's the first process. And then it's going to do a little bit of training, the model, and here it's going to look into many training mechanisms, algorithms, and what it's going to do in this training process is it's going to look into this data set, analyze patterns, features, relationships. You're trying to understand everything that the data has to give you, like all the characteristics that are underlying in that data set. So you're learning everything about the collection that you just have. And once you have those features, those patterns and those structures, then you want to represent it in some form. So this data representation, we can think of it as in a simple mathematical equation or a feature of vectors, some form of representing this data set. So once you have this data set, again, whatever the data representation, it's nothing but an abstract. You're taking the whole billions of data points and trying to gather all the important features and trying to represent it in one form. So then you're going to sample this data representation. That's where the generation comes. You're going to sample points from this representation, and you're going to decode that to produce the content that you want to generate. And then once you generate the content, you're going to evaluate it. That is a major part of the generative AI. So it's going to evaluate the content to see how close it is to the realistic sample. And whatever the difference is going to feed back again into the generation process. It's going to keep learning until it finally generates a realistic or improved quality product. When you're doing this iterative process, all you're trying to do is you're trying to adjust the parameters to get it as close to the realistic sample as we want. And then I want to talk a little bit about the generative models. There are many models out there, but these three might be a little more close to what we are reflecting today. One is the probabilistic model. This is very simple. In this case, what you're doing is you're trying to capture the distribution of the training data. And when you have the distribution, then when you're trying to generate the data, you're basically sampling from this learned distribution. So that's pretty much what we have here. And in this, again, what probabilistic distribution are you going to use? It all depends on the data set. For example, if it is a continuous data, we might go with the Gaussian distribution, or if it is a discrete, you might go with the categorical distribution, and so on. The most attractive part of these models is the GAN model. It's called the Generative Adversarial Network. This has two neural networks in it, and they're called a generator and a discriminator. What the generator does is it tries to come up with, based on the training data, it tries to generate generate the content. For example, let's say you want to generate a dollar bill, right? So the initial process, it might generate just a sheet of white paper, similar to the size of a dollar bill. The discriminator then is going to look at the real sample and the one that was generated, and it's going to produce the different characteristics. And those characteristics are going to go back to the generator again as input, and the generator is now going to retry again based on the input given by the discriminator. It's going to retry and get a better result. And the discriminator again is going to try to find out the differences between the realistic one and the fake one, and it keeps giving input to the generator. So this back and forth, this interplay will result in an increasingly realistic sample. So basically, it's generating, and then the discriminator tries to discriminate between the real and the actual content, and then it's going to share the differences to the generator. The generator is going to use those differences, basically change the parameters based on the differences given by the discriminator, and then regenerate the content, and eventually you'll probably get the realistic sample, closer to the realistic sample. The last one is the autoregressive modeling. This is based on conditional probability. So it's basically if you're trying to get elements in a sequence, so what is the probability of the next element given the current element? So it's like, if main application would be in the text generation. So what is the next word in the sentence given this current word, and so on. So those are the three simplistic models, the ones that are more easy to follow and understand here. So that probably will give you an understanding of how the generative AI and the modeling works. coming to what can generative AI do and what it can. As we said, the generative AI heavily depends on the training data set. If you don't have a training data set for a given task, it's going to fail that. Trying again. An example would be, let's say, if you have a robot that is going to solve Rubik's Square puzzle, right? And no matter what combination of the Rubik's Square you give, the robot is going to give you the final solution because it's been trained to do that. If you then, let's say, remove the squares, those tiny cubes, dismantle the Rubik's Square and give it to the robot, it will not know what to do because it's not trained to put it together. See that? So basically, it'll do whatever it's trained to do. And anything beyond that, it needs to be trained again. So that's pretty much what the gist of generative AI is. It is, again, like I said, it can do a lot of things that, like we have seen, it can generate music, text, images, code, 3D animations, models, all that stuff, but it has to be trained, and that involves a lot of training data and also computational resources. So that's kind of the intro to generative AI, how it works and so on. So I think I'll hand over to Dr. Latt, who's going to do the demo.
Okay. Oh, okay. Well, apparently I'm already starring in a commercial, so I don't for the university, so I don't want to hog the limelight. That's right, exactly. So I've been playing with what is now known as prompt engineering. And basically, prompt engineering is coming up with prompts that convince the large language models, which are using the learned from a huge corpus, to produce something which is usable. Actually, I'm trying to get it to solve simple logic problems. It's the thing that I am mostly playing with. I don't ask it to write essays about anything, and but I give it a. Well, last year, when I first started playing with them, I was giving problems to my classes and watch it solve them, or look at what it produced, because again, it can only produce what it knows. And so I would get things like. Oh, okay. Sorry, I can play that. I mean, no problem. I'm always worried about popping though, so I try to keep it far away from me. But the key is I could tell what textbook it was cribbing from when it gave me one of the answers. I knew whose textbook that was because I have used it in. But anyway, what I'm supposed to show you is it in action, and I'm not actually going to show you in action, at least not at first, because at first what I'm going to do is I'm going to show you a question. And so does this get there? So basically, what I've most recently read anyway on prompt engineering is what's referred to as the tree of thought model of prompting. And basically, I'm telling it to run 3 streams of consciousness simultaneously. That is, it's going to try and generate an answer to my question, and then it's going to have another one of its thoughts critique the answer that it got, and then a third one will critique that answer, and so on round robin until such time as either it finds an answer, or it can't, or decides it's sick of doing it, or whatever. So the key is the beginning of this is very boilerplate. This is the current boilerplate that the paper used. And so simulate 3 brilliant logical experts collaborating to answer a question. Each one explains, and they acknowledge their mistakes to each other at each step. Each expert refines and builds on what everybody else said. So what is my question? What is my question here? Oh yeah, I hit enter before there was actually a question. So there we go. Imagine this jetted die. It's got 6 different numbers on the faces. You can look at a corner of it. You can see 3 of them. What's the sum of those 3 faces? And so what's the lowest possible sum you can see if you have the numbers 1 through 6 on the die? What's the highest possible number you can see? And then is it possible, looking at the die, to see every number between those two? And it turns out they generate all the answers first. They actually do the hard work first because you can do it more easily. The answer is no, by the way, because the smallest number you can see is 6. 1, 2, 3 added together. The highest number you can see is 15. 4, 5, 6 added together. And it turns out that there are 10 different values there. And a die only has 8 corners. So if there are 10 different values and you can see 8 different sums by looking at the corners, there are 2 that get left out. So it took me a while to get to argue it, or get it to argue itself around to where it actually saw that there was a count mismatch. It does eventually do that. But the key is that when I ask it, because I'm using this 3-part model or this 3-part prompt, it actually builds the 3 experts talking to each other, and it's actually fun to watch because the expert 1 is typically a screen ahead of everybody else because expert 2 is responding to expert 1's answers, and then expert 3 is still further behind, and so it's an interesting thing to watch. But basically, they try and understand what you're asking. And if you watch this, you can see that they actually are able to get to the smallest and the largest numbers where they are. Oh, well, there we go. Got the interval. That's there. They got it from 6 to 15 is in fact the interval. They got that part correct. And then they started looking at. They basically generated all the possibles. Now, one of the keys is initially they took the constraint because they called it a die. They took the constraint that the opposite sides had to add to 7. And then I tried to get it to relax that. It did, and then it went ahead and done all the possibles. And then it finally thought of the idea that there are too many values in that little corner. But it kept wanting to basically generate this list. And I kept telling it, don't do that. That was basically my feedback. So there you go. It tells me what those are. And it says it didn't hit them. Well, what if we relaxed the sum to 7? And then it got confused. It had no idea what I'm talking about. Now, one of the reasons that it gets confused is exactly what it's using a more complex model behind it. But fundamentally, if you think about the RNN network, the last one that Grabowski talked about, it's always looking at the end of the sequence. It's always looking at the last most element in the sequence. And so therefore, this, sure. I have no idea. That one? That one? I have no idea. Welcome to, I don't know anything. Macintosh. I don't use it. Oh, no problem.
Saying it's still fuzzy, but I'll contact IT services. I don't think
I can make it bigger. But what I can do. Well, the key is it's always working at the most recent word. Whatever model it's building behind the scenes, however it's storing that information, it has each word is being used to search the space and generate a new position in that space based on what it had learned, the connections between these various encoded representations. And so it turns out that the word sums there is the last of my prompt. And I'm putting it the wrong screen. Sums is the last prompt. So therefore, it's trying to say what follows the word sums is what it's executing at this point. And the big deal is the different models. You pay more money for ChatGPT to get the various higher end capabilities. They drag along more words behind it, more tokens behind it. And so that's one of the key things. When you go up to a bigger model that has more of these points, and you go up to potentially a bigger number of tokens being dragged along through this. But basically, that collection of tokens is being extended by adding one new token on the end and forgetting the token that is oldest. Which is why when you have small sets of tokens, you can watch it lose its mind as it falls off the cliff. Because your entire question goes away because its answer has replaced the question. And if somehow there's some specific part of your question, so you always want to make sure your question comes last. The last thing in the prompt is actually what you want, because that'll move off last. But the other thing that's fun is it hallucinates. It finds connections between things that produces things that don't exist in the real world, because it found some connection which looks like it exists. So one of the first things I did was have it, describe a set of novels that were never written. And it did a great job. It's spy novels based in specific sub-region of Russia, and it continued to explain to me exactly how those spy novels didn't exist. But the other thing is that it gets things wrong. So I'm going to give you, I'm going to shut up now because I'm getting long. But what I'm going to say is, the one thing to remember is this is a collage. It has a huge amount of information, and it's piecing it together in tiny little pieces. Just like an artist has a whole bunch of artistic material to work with, and it chooses which pieces go in which part of their collage. But it's still only a collage. And by the way, they get programming problems wrong about that.
So, an unshare screen, I believe. I don't think we need, for now, unless you want to keep it to do examples later. Okay, so I was tasked for this meeting today with talking about how we can detect AI. And of course, we're concerned about in our students' work. And the bottom line is, generally, we really can't. So here's the thing. There are a zillion now, because they just kind of like proliferated out there, AI detectors. There's lots of them available. But the problem that has developed with them is that they are producing a huge number of false positives. The reason that they say, yes, this was generated by AI. And the reason this is happening is because what we've been talking about, for these last 20 minutes. You're using a system such as ChatGPT, you're putting in your prompts, you're getting your results back. Well, guess what? This all goes back into the training for ChatGPT. So by this time, these systems have digested so much data from all over the place that the kinds of patterns that the systems are looking to identify. And of course, these AI detectors are yet another AI trying to smoke out the AIs. Okay, so that's kind of mind-bendy anyway. But so they're looking for patterns that the AIs would produce because they are ginormous pattern generators. That is largely what's going on underneath the hood. Pattern detectors and then generators as well. So it could be useful to use one of these detectors, but we have to take it with a few kind of large grains of salt, because they do produce, as I said, a lot of false positives. And I'm not exactly sure what to do about that. And in our department, we were, like everyone, but we were very concerned because there's this idea that, well, okay, you would think a computer would be able to generate good, solid, clean code. But no, as Brian already said, at least half of the time the solution's wrong, because the systems are also going to be eating data from, subreddits and who knows what all, of people who posted wrong answers to questions, or students who are posting questions asking for help. So there's all of this not very helpful data out there. But in terms of detection, I don't think we're there yet. And with now the growing use of the generative AIs, or particularly these large language models, which is really what our thinking was focused on, because that's what ChatGPT and all of its cousins are, right? So particularly with more and more people using it, we're feeding it more and more training data, and it's just going to think everything is a reflection of itself. Of course, the word think is not appropriate, right? But, it will determine probabilistically that the probability is higher than not that an AI generated that. which is why we say think, because what I just said is really long. Do you guys have anything to add about detection? I really wasn't terribly successful in finding anything of particular use because there have been growing problems.
And with the new models that are coming up, detection is part of the learning process. So like the one that I talked about, the discriminator is actually acts as a detector, right? It's trying to discriminate between the content that's being generated and the real sample. So that differences are given as input back to the generator to generate a more realistic one. And this keeps going. So the detector will detect the differences, but then again, those differences are fed back into the generator to get more realistic samples. So this keeps going on and on. So the detection is hard because it's in the process. It's in the learning process. It's included in the learning process.
Okay, so I think that pretty much wraps up our presenting part. So we are happy to open the floor and the virtual meeting as well to questions, and we'll answer them as best we can. Yeah, here.
First of all, thanks very much. That was really informative and interesting. I just have a quick question about detection. I think we're talking mostly about text because we're educators who often take written assignments. But are there any differences in detection among the different types of media and modalities, really? So if you're a graphic designer, are there better detection methods for images, for example, or video generated by AI? Are the detection success rates any different?
I put it up watermarked. I couldn't speak specifically to image or video because we have dealt primarily with text. Oh, Brian has something.
I actually read headlines. I haven't read the full article yet today, but Glaze is the name of a product which is designed to try and keep AIs from scraping, or forces AIs that scrape your image to, Glaze changes the artistic patterning on the surface. So therefore, it looks like someone else's technique or somebody else's style. The one that I read about, which I have to follow up on, is they now have a package that does very minute changes to the pixel values inside of the digital image in such a way that it confuses the AI detection to think that a clown is a car. I haven't seen how this works yet. This is a pre-pub right now. It's not, the actual paper hasn't been accepted yet. It's in peer review. And I read the headlines and I was like, oh, I want to know how that works. Because I'm assuming it's something like Moiré patterns that aren't visible to us though, right? So they use pixel changes that are below the visual acuity of human eyes looking at the screen. But because the machine is using the highest resolution, color values that it can get, it has some wave pattern. I'm assuming wave pattern. I don't know that, but some pattern on the top of it that screws it up. So that's something that they're working towards, making it harder for AIs to scrape. It does not help with the AI generated image. Once you get the AI generated image, who knows, right? And again, the matching that takes place doesn't take place in the output space. It takes place at the instant before it does the back translation. So Scott was talking about the fact that it translates this into some internal mathematical model representation, and then generates the output, and then back translates it into the words you saw on the screen, right? Because it knows that this particular thing refers to this spot in this document, so therefore that becomes, this sequence of words or whatever that it is, or this sequence of lines or whatever it is in an artistic piece. Well, the key is the pattern matching is all taking place before it comes out as a picture. And so I don't think there's going to be a whole lot better detection capability. I mean, yes, they're talking about watermarking, so the watermark will end up in the final images. because you will train the AI to believe that a watermark that says Adobe Inc. across the middle of your page is the right way to make an image.
Just a quick follow-up, slightly off that path, but related to it. I read an interesting news article recently, I think it was like last week, that people were presented with sets of images that some were produced by human artists and some were produced by AI. And the task of the people in the study was to identify what's AI, what's human created. And they didn't have such good luck with identifying AI versus human. And when they could judge it, they weren't confident. But what was very interesting was that pretty much all the time, the subjects in the study preferred the human created art, even though they couldn't identify that it was human created and not made by an AI. So yeah, so maybe, you know, in terms of images, perhaps humans are the best detectors we have right now. Yeah. So and of course, there's no explanation about why. But you know, look, if you I don't remember who wrote the article, but looking at some of the pictures that they had, the images they had as examples in there, there is something quite intangible, but you know, that makes the images produced by human artists much more attractive. Somehow that something connects us to it that's, you know, more than just the kind of interesting that the AI was able to produce. So it's I don't know, maybe the detector's us. So there's another question. Oh, in chat. Oh, here, now I have to read. I don't have my glasses on. Okay. Okay, so we'll just take them from the top. Let me see. Okay, I've heard that detectors have more false positive with students who are second language learners or are from underrepresented groups. Are you seeing this as well? I don't know anything about that data. Okay, you guys can talk about it.
So one example is my own experience. When I bought the iPhone, when I was trying to use the Siri to translate voice into text, it couldn't do well because I don't have the accent. It's been trained with. But then over time, it learned my accent and then it was able to do well with it. So I do see that.
The key is there's a language-wise stereotypification. And the key is a second language learner or someone using, I mean, I know that, you know, what little French I can speak is always going to look exactly like what I was trained on because I have none. You know, so I can't, and that's good. That's going to match patterns because it's absorbed all of the same textbooks that were used to teach, you know, whoever's a language, you know, ESL learner learned from someplace. I'm just guessing that it's already inside there.
Yeah, so I guess just to follow up on that, it does go back. So Brian said that there's the language learning in the systems is somewhat stereotypified, right? Because it needs a training set from somewhere. And the training sets are not going to have the kind of wide representation. I'm sorry, I almost swept in the face. The wide representation that we would want them to have. And I don't know if you have some of the funniest videos that are out there on you know, Instagram Reels or whatever are people from Scotland trying to use an Amazon Echo, and the machine cannot understand them. It's quite hilarious. Anyway, so it is definitely part of the problem with the training sets. But over time, as they get as the system gets more data from its typical user, it's going to be able to adapt. What's the next question? If AI sampling is from error-ridden samples, would the product contain the same percentage of errors which could help to ascertain the use of AI? Percentage-wise, I would think it's hard to say, because there's also going to be a whole lot of error-free or something like that samples that they're training with as well. I think that just in terms of the raw number or the percentage of error in the product is going to be really variable and probably not especially high, but I mean, I don't know. What do you guys think?
I think one of the real problems is if you're trying to match the error rate to say that it comes from an AI, the AI was trained on 1 billion pieces of information, and characterizing the error rate in any given question in that set of 1 billion inputs is really going to be difficult. I don't see that as I don't see a foothold or a handhold where we can grab it and start pulling pieces out that would allow us to do that. Simply because the number is unknowable ahead of time. The first number is unknowable, so therefore comparing whatever the heck you get out of the AI, maybe it matches.
So this is where we're at right now. Your best guess, where is this all headed? Where are all these models going to go?
Skynet. Well, so just let's take a little step back for some perspective. Because AI has been in the consciousness of the field of computing, certainly in popular culture, since about the 1950s. Well, actually earlier than that. Alan Turing, of course it would be Turing, wrote the first paper on the idea of AI. Excuse me. In 1930. Do you remember the year? 7, 9, mid to late 30s. Yeah. Okay. So mid to late 30s. Okay. Proposing what is known as, part of the paper was proposing what is commonly now known as the Turing test, for how you could tell if you are, or when a system can pass this test, it is an AI system. Okay, because in the test, the human interrogator cannot discern whether they're talking to a machine or to a person. Okay, so that's the fundamentals there. So, and since about the, I'm going to say 1950s, when computing really started to take off after the Second World War, is really when electronic digital computing started to really ramp up to what we know today. AI, human level intelligence AI, right? General AI it's no more than 10 years away in the 1950s, and the 1960s, and the 1970s. Okay, so and continuing up until now. So there have been a number of rather alarmist and alarming videos of people who used to work at these companies and ringing alarm bells that the AI is going to be here in a couple of years and it's going to try to take us out. I don't think we're there. There is no ghost in the machine yet. I think part of what is really intriguing right now is that the results we're getting from these large language model systems, all these various generative AI systems, is much more impressive to us as humans than what we've seen before, because it does feel like the behavior is becoming more human-like. But think of all of the data it's learning from that was created by humans. Okay, so is the intelligence in the system, or is the intelligence in everything that it consumed to create its responses? So where is it going? I mean, if only I knew, I would be able to, to do that now and, do all kinds of things. So I think that I personally think that to some degree the shine is going to wear off as we use these things more and we begin to recognize more of the limitations of the systems. And of course, this has already been using AI to produce creative work has already been at the forefront of the SAG-AFTRA strike. They're still working on that. The Writers Guild of America, the use of AI generated product is at the core of those strikes. And there was a ruling by a judge recently, right, that says you cannot copyright stuff that has been created by AI. So that's, taken a little shine off of, what some folks wanted to use AI for in the realm of entertainment. So I'm thinking like with everything else that has come down the pike with AI, this seems like a really large leap, and it may be. It's a little too soon to tell, in my opinion, but we've seen that before. And it has always just kind of dropped out of sight because it doesn't deliver on its promise. Okay, so you either, to some extent, you have intelligence or you don't. It's almost like you need the whole package to be convincing, and it's hard to produce the whole package at once with a computerized system. So yeah, I nattered on a lot about that. You guys want to say anything? No? Okay, I don't want to touch that one. Okay. Sorry. Okay, do we have another? See, let's take one here. Okay. All right.
For the participants online and here in person, could we have a show of hands of folks who have tried generative AI, either through ChatGPT or there's a newer one called Claude or Bard? If you could, and we've got things recorded. I see one hand going up to online, and who can count here? Well, not speaking. Okay, so 7, 8 folks have tried it. I'm sensing so far we're leaning towards the cynical side of AI, and I'm wondering if you folks see opportunities for us as educators and administrators and learners for generative AI. If you see anything that's making you curious or optimistic, or just opportunities for us to exploit AI for the purpose of teaching and learning and all the other wonderful things we do here.
They're talking about, there are people looking at right now using it for teaching a second language. And I'm following that because I want to learn French. But it's an interesting take, because the claim is that it can present things to you and learn from your mistakes. That is, use the fact that you made a mistake, monitor that, see that you did it, and then present you with either the right grammar lesson or a bunch of questions that test you on the same thing, but only on the ones you missed, so that you don't get the boring ones that, you don't get another quiz of 10 questions where 9 out of 10 were easy. You get a quiz now where half of them are hard, right? Or where all of them are hard. And so that's one of the things they're working on. The other thing, I mean, I'll be completely honest, the thing that I use it for is inspiration. I type in, could you 3 exciting experts give me an example of a recurrence question that I could ask ask a bunch of first years, and it'll give me a couple of them. Now, one thing to keep in mind: never ask it for something funny. It has no idea what humor is. My wife just published her calculus text, and we were playing with it to try and get, because funny is what she does. That's the reason she has a textbook. And we asked it for inspiration, and they were awful. They weren't even inspiring. So.
For me, I mean, I'm talking with the classroom perspective. You know, there is no avoiding this. Like even if you tell students don't use this, there's no avoiding Chat GPT or any generative AI. So I was watching the info session by Howard when Chat GPT was just published, and one thing that came out of it, it's still stuck in my brain, is that at the end of a semester, you know, if you see the difference between a student who is armed with ChatGPT and did not take your class, and a student who is armed with ChatGPT and did take your class, that difference is going to define you as an educator. So that is stuck in my brain. So like, you can't avoid it. You definitely cannot avoid it. But, you know, there's something as an educators, you know, you got to dig in. And like I said, you have to show that difference. Whatever the difference that you're giving to students is your education at that point.
So I certainly agree with both what Brian and Supraja said. And I think that, well, figuring out how this can fit in the academic sphere is part of the charge of the AI working group. Okay, so this is really what our group is about. Yes, the tools are there now. The students know they're there now. But of course, we are concerned about students, I mean, we all, as a university community, students doing their own work as we have assigned it to them, because if they don't learn from the work that we assign, right? We all know that. So helping students learn where those boundaries are once we have some guidance, you know, as a university about what we think is appropriate, what isn't. So, you know, certainly, just kind of bottom line for me, and you know, to get ideas or that sort of thing, to gather sources. You know, so like a preliminary step of gathering some sources to go out and do some research with, assuming that the system doesn't make up sources, because it will. It will make up pretend papers that real authors wrote. It's crazy. As a part of a process, an early part of the process, but certainly not to produce finished work. So, you know, this is kind of the territory that we have to figure out, you know, as a faculty, as an institution, and then we can do a much better job of being able to guide our students to help them figure out how they can use the tool to their advantage while still learning what they need to learn as our students. So that's the big challenge. And you know, we know that students often get tempted by shortcuts. There have always been shortcuts, and this is, you know, another shortcut. And of course, shortcuts make for long delays in some cases. So, you know, this is really what our task as a working group boils down to, I think.
Oh, I'm sorry. No, I think everybody here, well, I'm older than lots of people, but the change when Google search became a regular thing that had consumed everything on the web. I think it's similar. It's not the same, obviously, because this does different things. But the changes in what we accepted in class, or the questions we could ask, or the papers we could request, and those sorts of things, in response to the fact that they could type in, you know, what is the theme of Hamlet, you know, and suddenly they have 8,000 pages telling them what it is, right? I think it's in many ways similar, and the problem is we're right at that beginning phase where the students may be better at the prompt engineering than we are. Again, I'm trying to, you know, keep up with all the papers, but I'm not keeping up with everything my students are doing to figure out how to get around this stuff.
Why do you have students who are attending online and
Okay, so this question is, what do you think the students think this is, wait a minute, where do you think the students think this is going beyond the ability to use it for faking their work?
That's a really good question. I mean, obviously, one of our problems is we're worried about them faking the work, but I think the question that was asked earlier about how do you use this in the classroom? How do you use this to enhance what's going on? I'm hoping that students are thinking about that too, right? Obviously, I want them, because if they come up with ideas, I want to hear them, right? I'm willing to admit that I don't use it every day. I don't go around thinking about how to, how it could teach me discrete math or whatever the heck it is, because I know discrete math. But the students who are using it could really be helpful as well, I think. Now, where do I think they think it's going? That's a good question. There are a lot of people who are, doomsaying, this will destroy work and we'll starve and, our tech overlords will become richer. And maybe that's right, but I don't feel it quite yet. Again, you say Skynet, and I say, hope not, but.
Yes, I don't particularly have an answer to that either. I mean, I could see that there can be concern about what does this mean for the future. What is the job market going to look like? Is the AI going to replace me? And when I talk about this in my professional practice class, sometimes we talk a lot about ethics. We talked about it in software engineering, and when I teach AI. We talk about these kinds of issues quite a lot. But of course, if you think back, 150, 200 years, the Industrial Revolution, right? Technology has been replacing jobs all the time throughout human history, right? And so yes, there is probably going to be some kind of fundamental shift if AI really sticks. And if some of the problems that do exist, particularly problems of bias within the behavior of the learned behavior of the system, if those kinds of things can be addressed, then just as has happened throughout human history, the new technology will replace the old, and then other things will open up for the human being so that the humans do other things. So, whether we end up with Skynet or whether we end up in Earth of the Starfleet, the Starfleet world, Star Trek, where it's practically utopian, and we have been freed from so many of the more crushing menial sorts of things. Who knows? It could, and there are a million other directions it could go.
I would just to add to that sort of question, I saw a quote from a professor who said, he tells his students, you're not going to lose your job to an AI, you're going to lose your job to someone who knows how to use an AI. And so it'll probably just become one tool in the toolbox that students are going to have to learn how to, and I'm reminded of at the Clarkson workshop, there was the one guy he ran the finance company, and he said, I am never going to hire someone to be the job of prompt engineer, but the accountants I hire will need to know how to engineer prompts. So I think that would be my guess of what students are probably looking like. How am I going to gain this skill in addition to the other skills I'm going to need?
Yeah, absolutely. And that is going to be largely on us. Figuring out how to do that and how to help them learn that will be on us as their professors and as their faculty, as their university. So that's why we needed this working group, right? So absolutely, it is a tool. Tools change, and here's a new one. It's pretty shiny right now, and we'll see where it goes.
If I could just read the comment that is up there from a student's perspective is a possible direction when teaching would be to guide the students on how to use AI. And I think this is speaks to Brian's point and your point about, whether someone who can use AI or just AI on it, who has attended your class or not. These are all questions that are bubbling up and that kind of make us all curious, rather than sort of going to fight or flight mode where our brains shut down as educators and as learners. The more we're curious about where this can take us, with what boundary conditions and what opportunities are there as well. It's exactly what we're exploring. So please, if you're interested, join us. And if you have tried any of the generative AI tools, whether you're a student, staff member, or faculty, we would love for you to share your experiences. We have a session coming up from Brian, which is about research and AI and opportunities for learning. And we also have a perspective from career orientation with learners, and that will be by Jenica in 2 weeks. So keep that in mind. And these are just the beginning, and we would really like this to be more participatory. So thanks for the input from you, Arnie, and then we have from Holly. I wonder if the large language models will almost suppress new knowledge and research, since it is rarer, as search engine results so often bury useful results. Almost inevitably suppress. Holly, that's very dark. Thank you for your question. It's not inaccurate, but it's dark. And it's dark. I'll change that. I'll tweak that. Any thoughts on Holly's comment?
I think there was one of the researchers who pointed out that about in the future, in the next few years, 90% of the content on internet, not necessarily published, the content on the internet could be generated AI content. And again, it all boils down to what you believe, how do you take that knowledge, in your research or in your classroom. How do you represent that? It's important.
I don't have a closing thought. So I don't know. I guess the closing thought is the systems are out there. We have to help our students learn how they can use them well, how they can use them ethically. So I mean, like anything, I think that giving our students a strong ethical foundation rather in their discipline in particular, but it's also in general, is really important and will be part of this work.
Yeah, thanks everybody. Very big thank you to the computer science department. And again, a shout out for 2 weeks time, we have a career related session, and then from Brian from the library's perspective. And the last thought I'll leave in your head is from a quote I heard from a session I attended a couple of days ago from York University, was think of yourself as a phys ed teacher or health education teacher in high school, and you are tasked with teaching sex education. So are you going to go abstinence, that route? If we're making the equivalent of ChatGPT or generative AI in general, do you think abstinence is going to work, or maybe the information and empowerment and critical thinking and ethical, moral elements that we all are born with in many ways, but also we can bring to the teaching and learning and research experience and then career development. So hopefully all of these are bubbling up for you. Please join our group and join our next sessions. And it was great having everybody here. So have a good evening and see you later.
Thank you.